So you all know a big gouge like this, rough out gouge, is the thing to do this, square it around, run it up here, rub the bevel, raise it till you get a chip, and then run with it. And by the way, the best way I've found, the quickest way to make the tool rest parallel with the axis of the lathe is to sight past it down to the lathe bed here, right? And I can see mine's out because the way that you start this is the way I started anyway, is I kind of pinch the tool off like this and run with it. I guess you call that an underhand, right? And your finger runs right in that hole there, and as long as you sway with it this way, you can get a cylinder. If you want to have a taper, then cant the tool rest, right? And go back to work. So with this, so everybody knows how to do that, right? Say yes. So to use the skew, again, start by rubbing a bevel. The edge that's actually cutting should be at about 45 degrees to the axis of the lathe. So back this way, rub a bevel, raise the handle, and draw it down a little bit. And it usually helps to have the tool rest a little bit high if you're going to do these planing cuts like this. And so again, here we go. You can go either direction with it. You can go overhand with it. And you want to cut with halfway to the short point. If you engage the long point, you will wish you hadn't engaged the long point. And it will be very evident to you that you've done that, okay? You have the tool up off the rest here to be able to engage this, and if you get very far back here, it's unsupported, and it will slam the tool down against the rest, and once again, you'll be alerted to that very quickly. And so, again, this can be done, right? You just saw me do it. We can do it some more. And notice where the chips are coming off. Okay? That's what you pay attention to. You don't want, in this case, you don't want to engage the short point. You want to work from the short point to about midway up the bevel. Is that evident? Know what I mean? Okay. So we can go from squared around. Yeah, but I've always found this to be more effective. So this leaves a pretty rough turning. It's got a little bit of a flat left on it here. But there it is, right? So what I said about getting multiple uses out of this tool is we're going to go from squared around here. And there it is. Some people do that. Now, we can turn that off, and if I slow my traverse, you can get rid of these ridges in here a little bit, right? But if you take this tool, if you'll notice it carefully, there's a short, straight section on either side of the rounded section, on both sides. And that is essentially this, okay? And so the same thing can happen here, and I don't have to swap tools. If I'm doing production turning and I've got 100 spindles to do, you know, it takes me a second or two to do this. But if I do that and get confused, it takes me a few more seconds. It's just quicker for me to go ahead and make that last pass, go really slow. And then way over there without engaging the corner. Or maybe you do something like this. And that's essentially what a skew does, right? You told me I don't want to do any sanding here. No sanding videos here. Okay, so you scarcely have to sand that. In fact, some of these, if you get it with a skew or with the gouge like that, you can get this to the point where if you sand it, you'll actually scratch it. So like I said, this is called a climb cut. The other thing you'll notice here is I'm not doing this. Yeah? I'm doing this. Shifting my weight, keeping it tucked against my hip, so forth, right? Is all this evident? Am I just running over plowed ground here? All right. So the other part of this video, I mean, we're going to make a rolling pin for sure, but the other aspect of this was to figure out how to use a skew. And so one of the things you do with a skew that's really important is if you have a spindle that has what they call a bolster on it, a square section. A lot of stair spindles will have a square section at the bottom with a dovetail on it or a peg, and then it'll get turned, okay? And so that edge, that transition that happens there is really good. There's several ways to do it. One way that does an okay job, okay, is to use a parting tool that's really, really sharp. And this is going to make a liar out of me because this is hard maple. It's very close grained. But you can see we've got some blowout here on the far sides of each one of these squares, right? And if you do it right, you can go ahead and sand that and get away with it, right? Say yes. The other way to do it is with a gouge, okay? So to do it with a gouge, you turn the gouge to the 6-12 position, right? And you engage only the tip, and you raise the handle into it. If you have it rotated like this, something other than 6-12, it'll skate off one way or the other because the edge is at an angle and it'll just spiral right off, okay? So you turn it to where the tip that's engaging the wood is sitting at 6 and 12. You understand? Go ahead. Time on a clock. Sorry about that. Yeah, well done. Thanks. So, again, 6 and 12, straight up and down. You might even push it a few seconds toward 12 something or other. So once you have even the slightest little tip here, slightest little material removed here, you have control over it because you've got something to rub a bevel against. Yeah? Same way when you enter the tool here, so if you push this in here and you don't have this exactly at 6 and 12, and you've got it angled a little bit, let's just say opened up to where you can see it a little bit, it'll skate off, okay? It'll do that with a vengeance if you go from square to round with this tool. So, down you go. And again, bring this back. Feel the cut with the bevel. Wander over this way a little bit, or raise the handle. Pick up a chip and chase it down. Right? And then rotate the handle as you get down toward the round part that you've just made. Now, you're going to look at that and say, oh, well, yeah, you got that nice curved bolster there, right? How do you get that square? And that is by swinging this all the way around here to where the bevel, okay, is perpendicular to your work. And charge on in. And you'll notice we have almost no blowout on the back side. But that's all about skews. We were going to talk about skews, or all about gouges. The other tools use the long point. And can you make that out? Can you make out the line I've got on there? On the video? Okay. When you do this, if you do it, when you do it, you want to mark out where that bolster is. But you don't want to do any more than just one of the four sides. If you chase that around with a square, you'll always wind up with it being a little bit off where they meet, yeah? Unless you've got exquisitely prepared material and a really good square and a really good eye for keeping that line all the way around there. If you do it on one and then look for it in this quadrant, not up here, but down here, you'll see it every time, okay? So again, we're going to start, in this case, off to the right side of the line that you're after. Engage the long point, and then go over to the right a little bit. And in this case, you raise the tool up, you keep the edge absolutely vertical, okay? If you lean it one side or the other, it'll shuck this out of here pretty quickly. Then you'll realize, oh hell, I should have kept that vertical. Right? Okay? So, again, and has any of you used... So you push in and you raise the handle at the same time, right? Have any of you used an axe before? Chop down a tree? You know, you don't just kind of chop into it all the time head on, perpendicular to the stem of the tree. You take a chop in this way, and you take a chop this way, and a chip pops out, right? And you do that again and again. That's exactly what happens here. You have to have a void to fold chips into. You understand? Does it make sense? Say yes. Okay, thank you. So you'll notice that the notch there has this really acute V form to it, right? And so to get it to be perpendicular along that line, yeah, this side of the bevel, right now, if I go straight in, this tool will wander off that direction, parallel with the bevel, right? Okay, so if I want to make it perpendicular there, I have to come over here and then do the same thing, where the bevel over here now is parallel with the line. Got it? Yeah. So, we're going to approach it a little bit at a time. Okay, you said you couldn't see the line, but I'll tell you I'm right on it. So then, all right. What else was I going to tell you about this? Oh, big skew, a lot of edge. So don't get yourself trapped into only using it up here at, according to the clock, would be, what, 3 and 9. If you use it like this all the time, you'll dull this part of the tool, right? And so there's nothing to keep, and then you got to go sharpen it because you haven't taught yourself how to turn it one way or the other here, right? The fact that it's a square cut, right, means that you can rotate this tool any way you want, and the cut will be the same. In fact, even going from square to round. Yeah? And so, dull the whole thing before you go sharpen it, right? Okay. Are there questions about this? Insults? Comments? Nasty things about my mother or anything? You all know that sound, don't you? That vibration there, harmonic thing. You can quickly quell that by just putting a hand on it. So squared around, that could all have been done with a skew. You know, there are a lot of turners that do that. Traditional, I think mostly European turners, just because that's been their tradition, and they've got an apprentice program kind of thing. And so you have to learn how to do these things. One of the other things that will help you if you really want to do it is reduce the lathe speed when you're using the skew to do those planing cuts. And that'll help you a little bit, I think. Let's see here. Pen. Oh, get my tape measure out of my sweaty pocket. 22 and a half, 11 and a quarter. So, a French rolling pin, like I said earlier, tapers on either side of center. They're not usually this long, but sometimes they're this long. Sometimes they're just shorties like this. But the quintessential thing about them is that they taper to either ends. European, other European rolling pins are just a cylinder. Sometimes they have a handle that's a self-handle, and sometimes there's a hole that goes all the way through, and there's a shaft in there to where the handle doesn't rotate while you're using it. So I am going to, let's see here. We're just going to arbitrarily say that the end of the rolling pin is about that big. Good idea to have this thing pointing away from you. You only have to get that come back at you one time and never mind. So, yeah, I don't think it's a straight taper. It's got a little bit of a roundness to it. But what I'm going to do is we're going to have a tiny bit of a flat here. That's how I'm going to make this. And we'll round that eventually. And I will make a straight taper, more or less, and then we'll modify that. The way we'll go about it here. So in this case, what I'm going to do then is, like I said earlier, I'm going to set the tool rest here at an angle that approximates the taper that I want to cut. Is that right? Remember how we got a cylinder? Now, the thing about that is by definition, as you run this, when you run a cylinder, it's absolutely straight here, and you're rolling down it just like this. When you do a taper, if you do that, you will run out of the chip. So as you go down the tool rest, you have to lift the handle to be able to maintain that kind of point of tangency with the cutting edge. Does that make sense to you? Smaller diameter, you have to raise the handle up. And so, in this case, you start at the small end, and each time you come back. So, a little bit of a flat there, and then we'll raise the handle a little bit, and you can see there's a very gentle bow to that, yeah? We'll come down here and do the same thing. Just as you go down, raise the handle up. Yep. Some of that is done by eye, and some of it is done, that's how you can, if you hold straight to it, right? And you have the gouge at a little bit of a scraping point here, right? As you move down, you can keep it at that angle, right? But if you want to attain a nice slicing, shearing cut, then as you go down, you have to raise the handle. Yeah? Okay. So once again, and then you can kind of rub your hand along it, and you'll feel if you've got a bulge in it here or there. And honestly, if it has a little bit of a bulge over a pretty big area, I don't think the dough is going to care about it too much, right? So a good way, if you really want to get anal about it, I guess, or be really accurate about it, one of the things you would do then would be to get a piece of really stiff-backed sandpaper, okay? And run that over there, and that'll generally knock off high points, yeah? And it'll make it really smooth. I've got a little bit of a bulge right here. All right. So again, kind of arbitrarily, we're going to mark off the width of my credit card cutter. And we're going to put a ball on these. Tom isn't here, but he wanted me to put a ball on the end of the rolling pin as a decoration. So, Yeah. If you put a spherical ball on the end of the rolling pin, whoa, that one got kind of creative. If you put a spherical ball on the end of there and you want it to be a sphere, I would advise you to take and make a template out of a piece of 1/8 inch or 1/4 inch masonite or something or other, and then work at it, right? It's much easier because to not make a sphere, but to make an oval or an egg shape. The problem is you got to pretty much do it on both ends, okay? So an oval, nobody's got any idea what it's a right one or a wrong one, and so I would advise you to go for that. Probably don't need this anymore. And I'm going to say on the left side, we're going to go in for a fillet. And there's kind of a counterintuitive thing about this, where if you put too much ornamentation on here with a lot of, sharp, nicely defined elements on it, those are areas where junk will hang up if you wind up using this a lot. And so a ball on the end of it, kind of maybe not a good idea if you're really going to use it a lot. If you got a real professional baker or somebody who really loves it. You understand what I'm saying? I mean, it just makes it a pain in the butt to clean every now and then. Anyway, we're going to put a little bit of a groove here. So again, put the tool at 6 and 12 position and raise the handle. If you put it at some other angle, it'll roar off one way or the other for you, okay? If you don't have it the other way, then it kites off to the left, to the right. You understand? Perfect sense? Say yes. That's right. So this was supposed to be a demonstration about using a skew. So I'm going to go ahead and make this bolster a little smaller. And in this case, the skew, we're going to use the short point, okay? And that's up here. And then raise it and roll it and raise the handle here, right? Let me clean this off first. Now you see that tiny little bead there, right? Tiny little burr. Can you make that out? Maybe we'll make it out on the other end here. Yeah. So that's where it's used there. So the bevel rides against the surface that you've just made. And if you want to follow through and use the skew, use the long point, cut all the way in. A peeling cut can be done with the skew. I don't find much use for it, but you can do it. And you put it up against here and rub the bevel, right? Raise the handle till you get a chip, and then you have to push in as well as raise the handle. So you have this kind of arcing path that the tool takes. Long point to get down to the bottom here. Yeah? Tom's always given me trouble about using a skew or the parting tool for doing a lot of this. I find it very useful. And this tool, have I given this demonstration before with a parting tool? Where it has actually 2, 3, 4, 5, as well as a long point here and here. You can use this exactly like a skew. Yeah? Right over here. You can also lay this over in this fashion, in a negative attitude. And in this case, I'm going to use it here. This is a sharp corner. I'm going to very carefully break that. Round it off a little bit. I have a hand on it here, my left hand, and that just quells some of the vibration there. So these fillets look a little big to me. I'm going to take those down. So another thing here about fillets that enter into a cove like this, and it's an aesthetic thing, and that is when you start a cove, the wall of it should be almost perpendicular to the spindle, yeah? And then it comes down and curves. If not, then they just kind of, if you angle them in there, some of them do that, I do a lot of historical spindles for staircases. And again, if there's some of them that are done that way, but they always look better, they look crisper, they're well defined, and I think you'll like them better that way. So, since this one is a little bit closer to the main section here, we'll make it a little bit bigger, that fillet. And this one here, a little further away. So you get this same idea of a taper here. It's just aesthetics. You can also use this edge scraping up here like this. You don't have to lay it over flat. If you lay it over flat like this and get it over the tool rest very far, it'll start to vibrate. You can roll it up on edge and use one or the other of them there. So we'll check these, since we ought to make them about the same. There we go. Uh-huh. Okay. Uh-huh. Yeah. You have to align the bevel with the direction you want to go. The cut will always proceed in the direction the bevel makes it go. Right? That's what I thought. I didn't. Yeah. I thought you were starting 612 and making a straight in cut. You enter the cut, and that's another thing. If you enter the cut, the critical thing, okay, is the part of the edge that enters the cut must be vertical. So it's possible for me to have this thing up here, my gouge at 6 and 12, but if I enter here, I'm entering with this part of the cut, right? This part of my edge. And again, it'll skate off opposite that direction. So it has to be just the tip there that makes that initial nick, okay, upon which now you've got something you can gain control over the cut. That's really a critical thing. Thanks for asking that. And I almost did it here. If you have the gouge pushed in, so when you have this thing going past, right, it should almost just be able to lift it past and not even make a cut, right? You got your gouge at 6/12, and you run this past, just almost tangent, right? In fact, you can come into it from below as well, yeah? As long as you just enter the cut with the very tip that is more or less vertical. And you can't do that, yeah, okay. Enough said. Sorry. So I'm just kind of by guessing, by golly, in this, it's a little bit wider than my 1-inch skew. Handy way. You'll find that a lot of historical turnings were done that way, where you have just the width of the skew, there'll be an element, another width of the skew, they have a bead, so forth and so on. And then there's a fillet, and that's what these elements are, okay? These little flats, those are called fillets. And so those little flats are, in this case, a little bit more than half the width of the actual cutting edge, right? So there's no real reason, like if I were going to do a bunch of these, I would make up a little telltale something to duplicate this, right? But I would not mark out. I would mark out this shoulder here, right? And this shoulder here where the bead starts. And I would have 2 calipers set for each of those diameters. But the width of that fillet, no, don't bother with it, right? Actually, table legs, stair spindles, all of that. When you walk up to the stairs, you don't look at the spindles, really. You don't put the critical eye, the magnifying glass on that. You look at the staircase, right? So this is something that has to look the same. It doesn't really have to absolutely be the same. If you're making parts that fit together, if you're making a machine, as a college, I made a treadle lathe, right? Works just like a sewing machine kind of thing. It's got a wheel on it about this big. And there were lots of parts there, pegs in holes that had to fit and be able to slide, and so forth and so on. All kinds of things that had to be right, not just look right. How are we doing on time? All right. Okay. And then that's also, the bead is about the same. So one thing about the bead here on the end, the knob, is it has to be smaller in diameter than the smallest diameter of the rolling pin, right? Or else when you tip it over here, this part of the rolling pin never makes it down to the table all the way, right? Probably a subtle thing, but it should be smaller than the minor diameter of the rolling pin. Doing coves. Do y'all know how to do coves? Yeah? Come into it 6 and 12, and then it should be at 9 and 3 by the time you get to the bottom of the cove. A lot of people say, oh, no, you can't come up the hill on the other side, right? You always go down into the wood. Depending upon the wood and the kind of kind of a cove that it is, you can kind of come up the other side. What's really important is that you don't have one curve coming down like this way and another one coming in here and undercutting it, right? Or you don't want it to come down here to a point. You want to make a nice radius, usually is the way it goes. There are some times, like if I duplicate spindles, I just did a big newel cap that had an elliptical, you know, so it comes down and then it turns in real tight. So those are just subtle things. If you do this stuff, you notice, and you have to duplicate them because somebody says, oh, I don't know. When you get down to the final shaping of elements, whether they be coves or beads, you can't look here where the cut's taking place. You have to trust that the cut will take care of itself and do a fine job. You look over here on this side of the spindle. That's where you can see the shape develop. We can caliper that, but it's important that we caliper that now. If you caliper it, if you know, particularly if the cove is really narrow, if you run your parting tool in there, you'll have two corners, right? And you still have to get down to the bottom of the cove. And so I always, you know, will caliper it as I go. Oh, that's a little tight there. We got a little bit shy on that one, but I think the rolling pin will work just fine. So what I said about coming up the other side, can you? Yeah, you might be able to see that. You can kind of scrape this side with the wing of your gouge. But you see, I'm not taking much off here. This is all about smoothing out little pieces parts here. It's not about taking off a lot of material. And once again, my trusty technique here with the this headstock really kind of gets in the way. That's not too bad, huh? So, another thing about turning something down slim like this on both ends, always turn this end off first. You're driving with this end. If you've got work to do down here, leave this end good and beefy to where it'll go ahead and transmit the power, right? Turn this end off down about as thin as you dare, and then come back and turn this one down as thin as you dare. I'm going to go ahead and turn that off so I don't get a bunch of black lines in my dough. And make some finishing passes here. You can see I'm just getting these little dusty shavings off here. I'm not taking off much. Ooh.
What are you using your rough thumb for when you do that?
It helps me.
Hold it off?
It's interesting that you notice that. My left thumb I put up against the tool here, and it just kind of stabilizes it along here, right? So if I just take this along here, it's really smooth, and if there are any bumps in it, then it kind of wants to run with it, right? However, if I put a finger down here, it's kind of resilient and I can hold it that way, right? If I put my thumb up there as well and kind of lightly grip the spindle so I don't burn the hell out of it, right? There's another way to kind of check and feel it. A lot of that, this, a lot of this is auditory. You hear the cut, right? You hear when it makes a mistake. You hear when it's going right. You hear when you don't have four corners on your tool, on your workpiece anymore, right? All of this stuff is sensory input to doing a good job. And so again, here, the thumb up against the, can you see that? Yeah, okay. There's one little spot there that kind of talked to me a little bit. That's not bad. Any questions so far? So this is long enough. If I had a short spindle, I'd go ahead and turn this all the way off and just hold it here without anything here and come around here and turn the other end off, and I wouldn't have to sand anything off of it, right? This is not exactly a short spindle. And so I'll turn it down about as far as I dare, and even I'll be a little conservative, because if I'm going to make that mistake, I don't want to make it in front of y'all. Yeah, this has got me up here like this because my tool rest is too high. And so we'll drop the tool rest. Oh, now it's a whole lot more easy here, right? There. Okay. I'm pleased with that. Any questions? Yes, sir. Do it again. I do, yeah. You can look at it, right? If it were a straight taper, you'd look at it and say, oh, yeah, that's a straight taper. And it's got a little bit of a roll to it, and I don't know, you could get a ruler, a straight arm, straight edge, and, if it were a straight taper, you'd be able to put it down on there. But, a radius, this is a broad radius. This is several feet radius here. And I don't know what it is, and it may not be a true radius. But again, I don't think the dough is going to care too much, okay? And so I was instructed not to do any sanding, so that's completely out. I don't think it needs it a lot, actually. So, yes, Charlie? You could? And so Another interesting thing about finishes, right? There are, I don't know of any finishes, the finish itself, that is toxic, okay? The things that are toxic in finishes are the volatiles, right? And the VOCs, they're called. So I would put almost anything on this. Tongue oil, linseed oil. I would advise against just using regular vegetable oils of some sort, just because they'll oxidize and get rancid and smell bad and may start molding for you. but a drying oil, a true drying oil like tung oil. The way that I use tung oil too is if you buy a tung oil finish in the store, you'll wind up getting about 5% tung oil and 95% other stuff, right? And so I've found that about a 50-50 mix of pure tung oil and naphtha or mineral spirits, and then get, clean cut or something or other like that. It comes in a kind of an orange can, a small can, maybe half a pint of Japan dryer, and use that specifically with tung oil. There's another drying oil, a drying agent in there called Japan dryer that uses iron salts to dry the tung oil, to cure the tung oil, and it doesn't work quite as well as the cobalt salts that are in the clean, I'm not sure, I don't remember what it is, but it comes in an orange can, and it's just a few drops for a quart, a tablespoon maybe, and it really accelerates the drying of the the tung oil. I use it a lot. I use that a lot as a primary coat on all of my, bowl turning, that kind of thing, and then I'll come over the top of it or not with a coat of polyurethane. So, I see several different finish manufacturers that say food safe. Well, the fact is they're all food safe, right? As long as they don't have volatiles in them anymore. So, and you liken that, so polyurethane, oh God, that's got to be toxic, right? In its cured form, it is as available to your digestive system as a piece of a milk jug, okay? And there lies the difference, right? Your body doesn't have the tools to dissolve polyurethane to get anything out of it, right? And that's about the long and the short of it. Furthermore, if I finish this with polyurethane and it took 10 years to wear off the polyurethane of constant use, and then I ate all the bread that I ever made with it, right? My exposure here is pretty low, okay? So I wouldn't say don't concern yourself with it, but know that fact, okay? So a salad bowl. If you make bowls that are utilitarian, I do. I finish them with polyurethane. I do the tung oil first to kind of bring out any what is it they call chatoyance in the wood, bring out color in the wood, and then cover that with polyurethane. It is unnecessary. You could easily just give it a heavy wax coat or leave it strictly with tung oil. Any of those things would be fine. If you're going to use them, and again, I wouldn't apologize about getting a scratch or a cut or something like that in them. The bowl that you make and gets used for salads for every Sunday meal gets some wear on it, and that's what we call patina. So they're made to be used, so bloody well use them. So any other questions? A rolling pin versus a... Yeah. Well, what it does is it allows you, as you're using it in this fashion, it allows the belly of it, it's like pounds per square inch kind of thing, right? If you've got a cylinder there, your weight is on the entire length of it, right? So this allows you to kind of move the dough around a little more easily. Make a couple of stripes this way and then rotate the thing, go the other way. It allows you to thin out the dough and spread it a little more easily. And I don't think that's an exclusive purview of the French. I think I think anybody that thought about it long enough, those bastards do know a little bit. Anything else? I'll pass this around if you want to see it. Don't worry. Actually, we'll do that now. There you go. It's another little spot there. It's got a hole in this end. Anybody